This question is also based like the previous question. It says find differential equation representing the family of curves. The given equation is x square upon a square plus y square upon b square is equal to 1, where a, b are the constants. The equation is given of an ellipse, as you can see. So very easy. Again you see that a and b are two constants. So you have to differentiate twice. Let's see this question. First of all, you must know what is the order possible for the differential equation. The order must be 2. The equation, given equation, x square upon a square plus y square upon b square is equal to 1. Let me make it as 1. Now I write differentiate with respect to x. Differentiate with respect to x. So what happens? This becomes 2x upon a square plus 1 upon b square, and what about y square? It is nothing but 2y dy by dx is equal to 0. Now you see, very easy, 2 and 2 becomes common, goes to the other side of 0. So what we are left with, x upon a square plus y upon b square dy by dx is equal to 0. That is your equation number 2. Now this is not the final answer, because dy by dx is only first order. You have to get second order because there are two constants. So I write differentiate 2 with respect to x. So what should be the answer? This is 1 upon a square, because x when treated with x becomes 1 plus 1 upon b square, and here you have to apply the chain rule, because you have y also, you have dy by dx also. So first term and differentiation of second plus second term, which is already dy by dx, and differentiation of first, which is y, so dy by dx multiply by dy by dx, n is equal to 0 as it is. So I make a line. What should be the answer like? 1 upon a square plus y upon b square d2y by dx square, right, plus 1 upon b square dy by dx whole square is equal to 0. Now you see, you have got this equation, and let's name this as equation number 3. Here you see, this is equation 1, this is 2, and that is 3. Now can I just write this answer here? I see that this equation number 2 and these equation number 3 can be treated if I multiply equation number 3 by x, because that gives me a simpler answer. So it is x upon a square plus xy upon b square d2y by dx square plus x upon b square dy by dx whole square is equal to 0, and that is your equation number 4. Why I did this, now you will come to know. See, this is x upon a square, and here in equation number 2 also you have x upon a square, so you can subtract them. Then you have y upon b square dy by dx. Here also you have some dy by dx sort of terms. So what you do is, you do equation number 4 minus equation number 2, and that will give you what? X upon a square cancels with x upon a square. So you are left with xy upon b square d2y by dx square plus x upon b square dy by dx whole square minus, because you have to subtract, minus y upon b square dy by dx is equal to 0. So see, this is a simpler answer to the question, and it represents a differential equation representing a family of curves. And you could also do one thing. What you could do is, you can take out b square in the denominator as common. So it is xy d2y by dx square, because 1 upon b square is common, goes to the side of 0, plus x dy by dx whole square minus y dy by dx is equal to 0. So that is the final answer that you can put as the solution of this important question asked in the CBSE examination year 2007.